We have an example problem here. An electronic device needs to be protected against sudden surges in current. In particular, after the power, DC, meaning direct current, so after the power is turned on, the current should rise to no more than 7.5 milliamps in the first 100 microseconds. The device has resistance of 150 ohms and it is designed to operate at 50 milliamps. What minimum value of inductor would you include to protect this circuit? Okay, so we're connected to a power source. When we say DC, we mean we're connected to a battery. So we have some sort of inductor and resistor connected to a battery. So we know the value of this resistor is 150 ohms. We're looking for the minimum value of the inductor. This wording, we don't want the current to exceed 7.5 milliamps in the first 100 microseconds. And the device is designed to operate at 50. What this means ultimately is if we were to graph the current as a function of time. We know the inductor doesn't allow current to instantaneously jump to its final constant value. This final constant value is the 50 milliamps. It's the current that the system or device is set to operate at. What this 7.5, there's going to be a point in time where the current is 7.5 milliamps. The problem is telling us that we don't want this time to be any bigger than 100 microseconds. It can be longer than 100 microseconds. It can take more time to get there, but we don't want it to take less time to get there. All right, so this is considered a charging circuit because we're connected to a battery. The current is increasing with time. So our equation for the current flowing in a circuit that's increasing in time, so that the energy is increasing in our inductor. Sorry, that's a T. So I've taken the equation we had, it is T over tau in that exponent, but we know tau is L over R. So I went ahead and jumped to that step where I put L over R in for tau. So we need to know what to plug where. Well, the system itself, if we look back at this graph, the system is designed to operate at 50 milliamps. That's the biggest this current is going to get to and eventually stay constant at. So that is our I naught. We're trying to find the value of the inductor, L. Well, they've given us this other information in that the shortest amount of time it should take to reach that 7.5 milliamps should be the 100 microseconds. So we can plug in the 7.5 milliamps for I at the time T of 100 microseconds. We were given the value of R as well. So it turns out the only unknown we have in here is L. So let me write this out. 7.5 milliamps will equal 50 milliamps times the quantity of 1 minus e to the negative. I'm going to go ahead and leave this as RT over L for a minute. I know the values. I'll plug them in a minute. I know to get the power out of the exponential function, though, I need to get the e, the function itself, by itself. So I'm going to divide by the 50 milliamps. That will leave me with 1 minus e to the negative RT over L. I'm going to bring e to the left side, so it's not negative, and so it's by itself, which means I'm also bringing the 7.5 over 50 to the other side. Now that I have the exponential function by itself, I can take the natural log of both sides. So on the left, I'm left with negative RT over L. On the right, I'm left with natural log of 1 minus the 7.5 over 50. Let's scroll up just a little bit. So L, I need to cross multiply. So I'm going to have the negative RT divided by the natural log of that stuff. So negative, our resistance is 150 ohms. Our time is the 100 microseconds. So I do want to put the 10 to the negative 6 in. Natural log of 1 minus all this stuff. Let me plug this into my calculator. My calculator is giving me 0.0922297, which of course I can't keep all these places. Coming back to the problem, at best we have 2 sig figs, so I would say 0.092. And the units for inductance is a Henry. That comes from knowing the time constant is L over R. That means that a second is a Henry over an ohm. So down here in my calculations, I have an ohm times a second. That's where the Henry comes from. So the inductor in this case is keeping the current from surging to protect the electrical device.